Hey y'all, welcome back to my channel. So today we are going to be solving equations by adding or subtracting. So these are going to be one-step equations for 6th grade. This is also a great review for 7th grade. So don't forget that I do make a mistake for my students to identify for extra credit. I hope this helps you all while you all are working at home, and let's get started. So let's first look at some notes. So we're going to be using the inverse operations to solve one-step equations. So when I say inverse operations, that means the opposite or the inverse of addition is subtraction, and the inverse of subtraction is addition. So when you're solving these, if you have addition, then you need to use subtraction. If you have subtraction, you need to use addition. You also will be hearing me talk about zero pairs. So you're going to make zero pairs to help you solve. And your goal here is to really just get your variable by itself. You're wanting to know what that variable represents. And I always tell my students, up until now, we had to be told what the variable represents. Now, since we have an equal sign, then we can find what the variable represents ourselves. So we're going to have to make zero pairs, and when I say zero pairs, that means one positive and one negative make a zero pair. And so we're going to use the algebra tiles again today. So that means, don't forget, I tell my 6th graders that this is an add one, this is a subtract one. So, but 7th grade, you can say this is a positive, this is a negative. So if you have one positive, one negative, or one add one and one subtract one, if you took one and subtracted one, that would be 0. So this is considered a zero pair. Okay, so when you're solving without algebra tiles, you can draw lines by the equal sign, and this just helps you to decide, okay, which side has the variable, which side does not. And don't forget that, and you'll see in the next one, what you do to one side, you have to do to the other. But you're going to move the number on the same side as the variable by using the inverse operation. So that's the addition and subtraction. And then don't forget to what you do to one side, you must do to the other. So if you subtract 1 from one side, you need to subtract 1 from the other. If you subtract, or if you add 5 to one side, you need to add 5 to the other side. You're wanting to get the variable by itself. Solve to find out what the variable equals. And then I always tell my students to do that 4th step and check yourself, because we have been plugging in to see, hey, is this a solution? So now you're going to check yourself by plugging in your answer and solving to the original problem. So you're going to take the original problem, rewrite it, and instead of putting the variable, you're going to put what your answer is, or the answer that you found for the variable, to check and see if it works. Okay, so now let's look at some examples. So first, I'm going to model these. So I'm going to draw a line down here. This line is going to represent our equal sign. Okay, so for this first one, I have x plus 4 equals 6. So I'm going to have 1x, and don't forget the green represents positive. So 1x, and then plus 4, so 4 plus 1s. And then we have equal 6. So we need 6 plus 1s. Okay, so now this side is the side with the variable, and we want to get this one variable by itself. Well, to be able to move these, you're going to have to make zero pairs. So remember, since I have yellow or plus 1s, I'm going to have to subtract 1s. So for each one of these, I'm going to have to get it to all equal 0. So I'm going to keep putting a subtract 1 Okay, so here I have made 1, 2, 3, 4 0 pairs. So since I put 4 subtract 1s here, what I do to one side, I do to the other. So I'm going to have to put 4 subtract 1s on the other side of the equal sign. Okay, so since I had 4 plus 1s, to be able to make them to 0, I had to put 4 subtract 1s. What I do to one side, I had to do to the other. So I had to put 4 subtract 1s on this side as well. So now I'm going to remove my 0 pairs. I'm going to take them away. So here's 1, 2, 3, 4. So now on this side, the variable is now by itself. I only have 1x. So now I'm going to have to take the 0 pairs away from this side. So that just leaves me with 2 plus 1s. So that means that 1x equals 2. Now I'm going to show you how you can do it up here as well. So we're going to, without the manipulatives. So just like the note said, I always tell my students, especially when we're starting out, draw those lines around the equal sign so that you know, okay, this is one side, this is the other side. What I do to one side, I have to do to the other. So this side has the variable, x plus 4 equals 6. So I do have addition here. So the inverse operation of addition is subtraction. Well, I'm going to have to take away all of the numbers that's with that x. So that's 4. What I do to one side, I know I need to come to the other side and subtract 4 as well. So now I have x plus 4, subtract 4, that's 0. Well, it's not necessary to write plus 0. So I just mark that out and say, hey, I'm done. I canceled that out. Bring my equal sign down, and then you actually do this problem. So 6 subtract 4 is 2. So now let's check ourselves. So I always tell my students, circle your answer so that it's easy to find. But we can check ourselves. So I'm going to rewrite the original problem. Well, I'm saying, hey, I think x is 2. Well, let's check and see if it's 2. So instead of x, I'm going to write 2 plus 4. And then I always tell my student equals 6. You're not solving it, you're bringing it straight down. So now I'm actually going to do it. 2 plus 4 equals 6, equal sign, and 6. Is this a true statement? Does 6 equal 6? Yes. So that means my x equals 2 is correct. Let's just, for fun and games, say that we accidentally got 3. So if I checked and I said 3 plus 4 equals 6, well, then 3 plus 4 is 7. Well, 7 doesn't equal 6. So I know that I would be wrong. So that's when I would go back, check my work, try to think what number I can plug in to make this statement true. So originally, when we were working with expressions, we said that variables can equal whatever number they tell us, whatever number we want it to equal. Now that we have the equal sign, there is a definite number, unless, and you'll find out in 7th and 8th grade, unless you can have infinitely many solutions, then you can plug in whatever number you want. But with these, we're just going to have one solution. So let's model this one more time, and let's do it, or I'll use manipulatives in the next one I'll show you. Yeah, the next one I'll show you how to do it with just writing it. Okay, so here's my equal sign. I have 1x, and then I have plus 3's, or 3 plus 1's. And then on the other side of the equal sign, I have 8. Whoop. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here I've modeled my equation. I need to get this variable by itself. So I have 3 plus 1. So I'm going to have to make 0 pairs. So to get this to 0, I'm going to have to put 3 subtract 1s. Well, what I do to one side, I need to do to the other. So I'm going to put 3 subtract 1s on the other side. So now I'm going to remove my 0 pairs. So remember, 0 pairs are a yellow and a red together. So here's a 0 pair. I just took all my 0 pairs away. So now I am just left with my variable. So now on this side, I'm going to have to take my 0 pairs. So now I'm left with 1x equals 1, 2, 3, 4, 5 plus 1s. So let's just work it out up here. So on this side is where my variable is. The 3 is with the variable, and we're adding 3. Well, the inverse operation of addition is subtraction. So what I do to one side, I have to do to the other. So now this cancels out and leaves me with just x. Bring your equal sign down, and then 8 subtract 3 is 5. So there's my answer. And sometimes I tell my students just rewrite, because sometimes those lines will make it look like a 15 or a 12 or something like that. So now let's check. So we're going to write the original equation. Now I'm saying that 5 is my solution. So I'm going to plug in 5 for x. 5 plus 3 is 8. Does 8 equal 8? Yes. So I know I am correct. Okay, so now I know some of y'all do not have manipulatives at your house, unless you live with a math teacher. So I'm going to show you how you can do it without. So you can draw it out. You can still draw your lines. So I'm going to have 5 plus 1s. And I always put my little positive sign or my addition sign in there. Then I have a variable d, and then I have 1 plus 1s. So now I need to make 0 pairs, and I need to use a side that has the variable. So I'm going to have to draw a negative or a subtract 1 beside of it. Since I drew 1 here, I need to draw 1 over here. So then I will go through and circle my 0 pairs. There's a 0 pair, here's a 0 pair. So then I just kind of cross them out because, hey, that's 0, I don't need to count it anymore. So on this side, I have d, and it's okay to have the equation on the other side. That's fine. You can still model it the same way. So I have d equals 1, 2, 3, 4. And so you can draw your lines up here. Now my variables on this right side, I have an adding 1, so I need to subtract 1. What I do to one side, I do to the other. Now this cancels out and leaves you with just d equals 5 subtract 1 is 4. So then if I'm wanting to check, 5 equals d plus 1. 5 equals, now I'm saying d equals 4. Well, 4 plus 1 is 5. Does 5 equal 5? Yes. So now let's look at this example. I'm going to do it without modeling. Well, let's model this one. So I have a long tile for C. Then I have 4 plus 1s. And then on this side, I'm going to have 5. So now I'm going to have to make 0 pairs over here where I have my variable. I'm going to have to add 1, 2, 3, 4, subtract 1. So that means on this side, I'm going to have to put 4 subtract 1s. So now I'm going to circle my 0 pairs. And they cancel each other out. And then also circle the 0 pairs on this side. And I cancel them out. So now I have C equals 1. So let's check with our work. So I'm going to subtract 4 on both sides because I have addition. Inverse operation of addition is subtraction. So that cancels out, leaves you with C equals 5 subtract 4 is 1. And so we can check ourselves. C plus 4 equals 5. Now I'm plugging in 1 for where I see C. 1 plus 4 is 5. And does 5 equal 5? Yes. So I know that C equals 1 is my solution. Oh, I forgot to write it over here and circle it. Okay, so now, sorry guys, this is example 3. Now let's look at subtracting. So we're going to model it. I want to model this one because this one's kind of big and I do not have 49 plus 1s. So I'm going to draw my line. I have 1 variable. Now I have 5 subtract 1s. And then 8 plus 1s. Okay, so here's my equation modeled. I'm going to have to make my 0 pairs on the side with my variable. So I have 5 subtract 1s. Now I'm going to have to put an add 1 for each of my subtract 1s. So on this side, I have now put 5 add 1s. So on the other side, I'm going to have to put the 5 add 1s because now, remember what I do to one side, I do to the other. 1, 2, 3, 4, 5. So now let's remove our 0 pairs. So now I'm just left with my variable. On this side, I didn't have any 0 pairs, and that is okay. So now I have y, because my variable was y, equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so now let's use our inverse operations up here. So I'm going to draw my lines. Now, I don't know why I was starting to write that, but y subtract 5 equals 8. So now I have subtract 5 with my variable. Inverse operation of subtraction is addition. So now I'm going to add 5. Notice I'm not changing that number. I'm still using that number because I need it to be 0. What I do to one side, I have to do to the other. Now this cancels out and leaves me with just y equals, well, 8 plus 5 is 13. So let's check ourselves. Y subtract 5 equals 8. That's my original equation. Now where I see y, I'm going to plug in 13. Well, 13 subtract 5 is 8. 8 equals 8. Yes, so I know that y does equal 13. So now let's come over here and do this without modeling. I have b subtract 12. So since I have subtraction, the inverse operation is addition, and I'm adding 12. What I do to one side, I need to do to the other. So now let's add, or let's bring our b down. This cancels out, and now let's add here. So that is 51. b equals 51. So now let's look at 2 more examples. So remember, you can still draw out and model at home if you need to. I'm just not going to sit here and draw out 98 ones and 14 ones. So let's draw our lines to separate one side and the other. So now I have p subtract 30 equals 42. So that subtract 30 is with my variable. So the inverse operation of subtraction is addition. What you do to one side, you need to do to the other. So now I have p. This cancels out, so my variable is now alone. And then 42 plus 30 is 72. So I'm saying p equals 72. So now let's check ourselves. Now where I see p, I'm going to plug in. Oh, that's supposed to be subtraction. So now 72 subtract 30 is 42. And does 42 equal 42? Yes. So p does equal 42. So last example, I'm going to draw my lines. Now I have 98 equals x subtract 14. I need the variable by itself. I have subtract 14. So the inverse operation is addition. What you do to one side, you do to the other. So now this cancels out and leaves me with x. And 98 plus 14. So that's 12 and 10 and 11. So 112. So now let's check it to see if that's true. Now where I see x, I'm going to plug in 112. And so 112 subtract 14 is 98. Does 98 equal 98? Yes, so this is true. Now I will say a lot of students like this form. So problem equals and then the answer. So now this is flipped. So I always tell my students that is okay to flip it, but just make sure you write it exactly the same. So that will go into effect when you start having negatives and dividing and multiplying and all of that. So just be careful when you do flip it. But it's okay to put the answer to the right. So I hope that you all enjoyed this video. I hope this helps you while you all are working at home. Don't forget that you can leave in the comments any topic that you would like to see a video on. Don't forget to give this video a thumbs up. And don't forget to hit that red subscribe button so you can stay on top of all the videos that I'm making while you all are working at home. I hope y'all are staying safe and at home, and we will see y'all next time. Bye, y'all.